Hello students, today we shall discuss Neet Test-4 Solutions for the chapter Aldehydes, Ketones and Carboxylic Acid. So start with the first question, which is IUPAC nomenclature. Okay, they've given this compound. We have to give IUPAC nomenclature for that. Very easy question. So basically we'll take this as a parent chain. This is a parent chain, and we have to give topmost priority to this ketone group. So we should start numbering from this carbon. 1, 2, 3, 4, 5. So now this is 4-chloro pent, because I have 5 carbon atom pent, and carbonyl group is at second position. So it is pent 2 1. So this is option B. Okay, next question 137. The chemical test to distinguish between the following pairs of compounds are. Okay, they've given 2 pairs of compounds. Now we have to give the chemical test. The first compounds are propanol and propanone. So these are aldehyde and ketone. We know that for aldehyde and ketone we have either tolerance test or Fellings test. So in option C and option B, we have tolerance test. Okay. Let's check second one, acetophenone and benzophenone. How is acetophenone now? Acetophenone is this COCH3 and benzophenone is this. Both are ketones. Obviously, we cannot distinguish with azodide test or any other test. But we have iodoform test. And what does iodoform test help us with? It will help in detecting this methyl ketone group. I have methyl ketone CH3CO group in acetophenone, but I don't have that group in benzophenone. So obviously iodoform test will help me distinguishing between acetophenone and benzophenone. So it should be tolerance test for first and iodoform test for the second. It should be option B. Okay, next question. Name the following reactions. Okay, they have given the statements of 2 reactions. Now we have to find out which reaction statements are these. So the carbonyl group of aldehydes and ketone is reduced to CH2 group on treatment with zinc amalgam and concentrated HCl. Yes, this is one of a named reaction where your carbonyl group, either it is aldehyde or ketone, it is directly reduced to hydrocarbon, right? So this can be carried out using Wolff-Kishner or Clemmensen reduction, but since they have given zinc amalgam, it should be our Clemmensen reduction. So it should be answer C. But let's check the second statement as well. Aldehydes that do not contain alpha hydrogen atom undergo self-oxidation and reduction reaction on treatment with concentrated alcohol. Okay, this is our Cannizzaro reaction, right? For example, benzaldehyde, formaldehyde, which doesn't have alpha hydrogen, they will undergo self-oxidation and reduction, and they will give Cannizzaro reaction. So option C should be the answer. 139. The general formula CnH2nO2 is for open chain. They've given diketones, diols, aldehydes, and carboxylic acid. Since we have studied carboxylic acid, we know that, for example, if we take, let's say, CH3COO, simple carboxylic acid we can take. If I have to write the molecular formula for this, C234H4 and O2. So now try to fit this in this general formula. Cn, that means Cn2, CH2n, 2 into 2, 4. Yes, I've got 4. And O2, right? I can write this general formula for carboxylic acid. So the answer should be carboxylic acid. Moving on to 140th question. Okay, which of the following reaction will not produce benzaldehyde? Yes, very good question and very easy question. So if you observe the options, you straight away given the reagents, it's all, most of the reactions are named reactions, right? So option C, they're adding carbon monoxide and HCl. This is our Gattermann-Koch reaction, and Gattermann-Koch reaction will give benzaldehyde. So this will give benzaldehyde. Okay. And this is also Gattermann reaction, even this will give us benzaldehyde. And this is our Stephen reaction, right? Here we have taken aromatic ring. Here cyanide group will be converted into CHO. Stephen reaction, even this will give us benzaldehyde. Coming to option D, this will not give me aldehyde. This will give me ketone. What are we doing here? We're treating cyanide with the cyano group with Grignard reagent. What will happen? C triple bond N and Grignard reagent CH3Mg Br. So if we take positive and negative, the polarity minus plus. So you just add this. So you'll get NMgBr. Now if you hydrolyze this, what did I say? This whole compounds, this whole group will be substituted by your oxygen atom, right? The easy trick that I told you to, that I asked you to remember. So this will give me acetophenone, a ketone. This will not give me benzaldehyde. So this is a reaction which will not yield benzaldehyde. So the option D is your answer. Okay, coming to 141 question number. So they've given this reaction and they're asking us to find A and B. Okay, they've taken the same reactant, but the reagents are different. Okay, observe this. Let us find out B first. B2H6 in peroxide. This is a reaction wherein we'll get anti-Markovnikov product. Preparation of, we have studied this reaction in preparation of alcohols part, right? So whenever alkenes are treated with diborane in peroxide medium, we'll be getting anti-Markovnikov product. I mean, we'll be getting alcohol, but the addition is anti-Markovnikov addition. So what happens in anti-Markovnikov addition? The negative part will move to the carbon containing most number of hydrogen atom. So I have a double bond over here. So now I'll be converting this double bonded alkene to alcohol. But which alcohol? The OH will move to carbon containing most number of hydrogen atom. So here the hydrogen atom is less. I mean, you don't have hydrogen atom at all. But here to this carbon, we have more number of hydrogen atom. So we will be adding OH to this carbon. That is our anti-Markovnikov addition. So it is CH2OH, and this will stay intact. Okay. So this is your B. This should be your B. Now coming to A. So what is it? We are adding sodium borohydride, which is a reducing agent. What it will do? It will just reduce your ketone, right? Ketone to alcohol. But what kind of alcohol I'll get? Since it is a ketone, we'll get secondary alcohol. Just reduce this. What we have to do? We have to break a bond. We'll add one hydrogen here and one hydrogen here. So let's do the same. OH, and this part will remain intact, no changes. So the answer should be this. Do we have this? Yes, we have. Where is it? Okay, A is this, A, and B is this, right? So 141 option A is your answer. Okay, identify the reactant. Look, this is such an easy question, right? This is our Gattermann-Koch reaction. We have taken benzene, and you're converting benzene to benzaldehyde, right? You have taken aluminum chloride and HCl, and the other reagent should be carbon monoxide. So it should be option C. Direct reaction, named reaction. Okay. The increasing order of the rate of HCN addition to the compounds A to D. So this has to do with reactivity. And whenever we speak about reactivity, we should consider electronic effect, that is inductive effect, and we should also consider steric effects, right? So we know that due to these inductive and steric reasons, aldehydes are more reactive than ketone, right? Because in aldehyde, one side you will be having R group and in another side you will be having hydrogen. So less bulkier. So less bulkier means the attack of nucleophile. In this case, the nucleophile is Cn minus is very easy because I have only bulky group at one side, not on the other side. So comparatively, this is better than the ketone wherein I have bulkier group at on both the sides. So other reason is our inductive effect because since we have increased the R groups number in ketone, they will increase the electron density on this carbonyl carbon. But we need less electron density on carbonyl carbon, right? This carbonyl carbon is polar and this carbon becomes positively charged, electron deficient. So this alkyl groups will increase the electron density on this carbon by inductive effect. So if it is increasing the electron density, then nucleophile, which is electron rich, which wants to add to this carbon, will not add to this carbon very easily, right? So now we have to think, yeah, what are all the options you have? You have three ketone group and only one aldehyde. So obviously this is more reactive, A, and we have A in all the three options. Let's see these three. You have simple acetone where the alkyl groups are simple methyl. So here steric conveyance is bit less. And here in the option C, we have bulkier phenyl ring. And here we have two bulkier phenyl ring and also the inductive, the effect, electron releasing effect is moles here due to resonance. So this D should be least reactive, then C, after that we have B and after that E. So your aldehyde being most reactive comes first, then simple acetone comes next, then acetophenone comes next, then your benzophenone. So it should be option D. Next. So they are asking you to find A in the below reaction. Again, they're asking you to find a reactant. And this is also a named reaction. This question is also based on a named reaction. And that reaction is Rosenmund reduction. In Rosenmund reduction, we will take benzoyl chloride. Where is it? Benzoyl chloride. Option A. This will undergo reduction in the presence of barium sulfate to give benzaldehyde. So this is straight away a named reaction, direct reaction. Coming to 145th. Which one of the following can be oxidized to the corresponding carbonyl compound? Okay, so what do we have? We have phenol. The oxidation of phenol is not very easy. So let us not consider this as of now. And next again, orthonitrophenol, it is also not easy. 2-hydroxypropane, can we do this? 2-hydroxypropane. So this is propane. I can oxidize this, right? If I oxidize this, so we will get how to oxidize. Either you remove hydrogen or add oxygen. So here we'll be removing our hydrogen. So we'll be getting a ketone. We have a carbonyl compound now. So this can be oxidized to carbonyl compound. So why not this? So if you take 2-methyl 2-hydroxypropane, it is like this. So this is a tertiary alcohol. We cannot simply oxidize tertiary alcohol, right? We cannot oxidize tertiary alcohol. We can only oxidize primary and secondary alcohol. So since this is a secondary alcohol and it can be oxidized to ketone, it will give us carbonyl compound. So it is A. 146th question. Which of the following cannot be made by reduction of ketone or aldehyde with sodium borohydride? So we know that when ketone is reduced with sodium borohydride, we'll get secondary alcohol. So when aldehyde is reduced with sodium borohydride, we'll get primary alcohol, right? So we have to look for that. We have secondary or primary. Here we have primary alcohol, so yes, we can get from the reduction of either two. And we have secondary alcohol, yes. 2-methyl 1-propanol. Even this is a, if you write the structure, 1-propanol means it's a primary alcohol, right? Again, this is a primary alcohol. So even this can be reduced to this can be reduced by ketone. You can get this by ketone or aldehyde. But what about this? What is this? This is a primary alcohol, so you got it. D, what about this? 2-methyl 2-propanol. I think we have written this somewhere here. Let's write it again. Two methyl 2-propanol is this. Right. So this is again a tertiary alcohol. So you cannot get tertiary alcohol by either ketone or aldehyde. So aldehyde will give primary and ketone will give secondary. So you cannot get tertiary alcohol from both of this. So it's option D. Okay. Which will give Cannizzaro reaction. Okay. What do we have? Always remember for Cannizzaro reaction, we need a compound wherein you don't have no alpha hydrogen, right? We don't have alpha hydrogen. So in acetaldehyde, we have alpha, so it cannot give Cannizzaro reaction. In benzaldehyde, do we have alpha? No. So benzaldehyde can give Cannizzaro reaction. So coming to this trichloroacetaldehyde. So even though we feel that here, as we don't have the alpha hydrogen, it can give Cannizzaro, but no, even it cannot give Cannizzaro because what happens in Cannizzaro reaction, if you observe the mechanism, the first step, very first step is the action of base on this carbonyl carbon. Okay, when this happens, let's say this has formed. Now this negative charge will again form pi bond and this will release. Okay, this released CCl3 minus will again take away one of the hydrogen as H plus. So if it takes away those hydrogen as H plus, then it will form CHCl3. So this group will move away and it will form stable chloroform. So I cannot get the products which we normally get from the Cannizzaro reaction. What do we get from Cannizzaro reaction? We'll get an alcohol and a salt of sodium salt or potassium salt of carboxylate, right? But here we don't get those two products. Since we are not getting the same product as we get in the Cannizzaro reaction, we cannot say that this gives Cannizzaro reaction, right? So this will give me CO minus H. Now this can take away Na plus from the solution. It can give sodium format, but as I've not got the another alcohol product, I cannot say that this gives Cannizzaro reaction. So only your benzaldehyde having no alpha hydrogen will give you Cannizzaro reaction. Okay, next, coming to 148th question. In the Rosen-Munz reduction, barium sulfate here. Okay, what is the role of barium sulfate in the Rosen-Munz reduction? So in the Rosen-Munz reduction, we use reducing agent, our hydrogen gas over palladium, and this palladium is acting as a catalyst now. So what are we doing in Rosen-Munz reduction? we will be taking benzoyl chloride and this is being reduced to benzaldehyde, right? So you just remove that chlorine and you just add that hydrogen. So reducing it now. But if in this solution, if it retains as it is, it can again undergo further reduction to give benzyl alcohol as well. So we don't need this. We just want benzaldehyde. We want this product. So what do? We add barium sulfate. So this barium sulfate will deactivate the palladium surface. So if it deactivates the palladium surface, now palladium, which was acting as a catalyst, cannot carry out the reaction further. So that's why we add barium sulfate. So option should be C. Okay. Coming to question number 149. They have given a reaction which is Canizaro and they've mentioned it as well, but we have to find out what kind of Canizaro is this. So clearly we can say that this is intermolecular Canizaro reaction. So how is it? If it is a crossed Canizaro reaction, I should be taking one of these compound that's been given and I should be taking any other aldehyde or ketone, any other. That should be cross. That would give me cross Canizaro reaction. And if it has to be intramolecular, intra means inside the molecule, the reaction should happen. So if it should be intramolecular, you should get both the products inside this molecule only. For example, you might get CH2OH and COONA. Okay, in the inside the molecule, in the same molecule. But here I have got the alcohol in one and carboxylate in other. So this should be intermolecular. So you should take two dicarbaldehyde compound and then this on NaOH will yield this product, alcohol and carboxylate, reduced and oxidized product, self-reduced and self-oxidized product. So this is intermolecular Canizaro reaction. 150. In the above reaction sequence, the product C is, okay, they've given an alkene and bromine and CCl4. We have studied this reaction in haloalkanes and haloarenes where your bromine will add to this alkene, right? This can be, treated as a test for unsaturation as well, right? You just have to simply add bromine to the double bond. Next, what are we doing? We are adding KCN. So this will be K plus and Cn minus. Now I've got another nucleophile. This nucleophile will substitute this bromine. So you'll get okay. Next, they have given dilute HCl. This we can consider as hydrolysis step, acidic hydrolysis. So acidic hydrolysis of nitriles will yield carboxylic acid. We have studied this in carboxylic acid part, right? It will give me carboxylic acid. So the answer should be B. When calcium acetate is distilled, it will produce which of the following compound? Okay, what is calcium acetate? It is something like this. This is our calcium acetate. So when this is distilled, so we have to find out the product. Always remember, in this case, we'll give calcium oxide. This will take away this electron and it will form calcium oxide. And we have the possibility of getting carbon dioxide from this, right? We can get carbon dioxide as well. One is calcium oxide, carbon dioxide, gone. So now this CH3 will attach to this carbonyl carbon. So you'll get acetone, a ketone as a product. So the product should be acetone. Okay. So it should be C. Option C. Okay. 152nd. 3-pentanol on reaction with aluminum tertiary butoxide in the presence of acetone gives. Look, your aluminum tertiary butoxide is an example for oxidizing agent. It's a strong oxidant. It's used in many open your oxidation, different oxidation process. So now I have an alcohol. If you observe this alcohol, 3-pentanol. So 3-pentanol is like this, right? So write the structure. So this is 3-pentanol, sorry, 3-pentanol. So this is a secondary alcohol. Secondary alcohol on oxidation will yield a ketone, right? Same thing, ketone. Now I will get a ketone. Okay, CH2, CH3. So this is 3-pentanone, 5 carbon atoms, same as it is. We just converted this alcohol to a ketone. We just oxidize this. So this aluminum tertiary butoxide will act as an oxidizing agent, right? So you'll get option C as an answer. Okay. Next question. So they have given acetophenone and strong reducing agent lithium aluminum hydride. I have a ketone, and what does ketone get reduced to? Will get reduced to alcohol. So what kind of ketone we have? We have acetophenone. So how to reduce this lithium aluminum hydride? Act as a reducing agent. So you just have to break this bond and you will add this pH, COH, H, CH3. Simple question. You just have to reduce this. So it should be option B. So next question. The product formed in the aldol condensation of acetaldehyde. So this is a straight away question from your NCERT textbook, right? It should be aldol. Yes. So we can straight away eliminate this product because in aldol we need to have one OH and another CHO group. But here we have only aldehyde group. So this is completely not possible. And if you observe option C, here you have one hydroxyl and one ketone. This is COCH3, right? So even this is not possible, right? So let's see. Acetaldehyde is this. So in aldol condensation, we'll be adding a base. So this base will abstract this acidic hydrogen or alpha hydrogen. So you'll get CH2 minus OH. So this will react with another molecule of acetaldehyde now. So since this bond is polar, now this carb anion will attack here. So you'll get COH, CH, CHO, right? So this is written after the addition of H plus as well. So you will get hydroxyl group next to the carbon atom. Very simple method to remember. The aldol which you always get is beta hydroxy compound, right? That means the OH group should be on beta carbon atom. So aldol is beta hydroxy compound. So here in option A and option B, if you observe, so this OH is attached to the carbon which is next to the aldehyde carbon. So this aldehyde is a functional group and this carbon is a alpha carbon, right? Next to the functional group. So now to this carbon your OH is attached. So this is alpha hydroxy. So it cannot be your product. It should be beta hydroxy. Here OH is attached to beta carbon, not on alpha carbon. So this is a simple answer. Can answer this in 1 to 3 seconds, right? Very easy. Beta hydroxyaldehyde. So it should be B. You don't have to, actually go through the mechanism. You don't have to write the mechanism. I just simply showed you the mechanism. It's just very easy. Next, Wolff-Kishner reduction reduces Wolff-Kishner reduction and Clemmensen reduction. In both the case, we'll reduce this carbonyl group. Either it is aldehyde or ketone to respective hydrocarbon. So we have a triple bond, COOH, no. Just ether group, no. So it should be aldehyde group. Okay. Aldehydes can be oxidized by Tollens reagent, yes. Pelling solution, yes. Benedict solution also. Benedict solution is the mixture of copper sulfate and sodium tartarate. And also you will add sodium carbonate. So even this will give carboxylic acid. I mean, here you're oxidizing in Tollens and Pelling solution, you're oxidizing aldehyde to carboxylate ions or carboxylic acid. In the same way, even Benedict solution will give the same product. Okay, even this can be considered as a test for aldehydes and ketones. Okay, so all of these can oxidize our aldehyde. So it's D then. Okay, now this is next question is kind of your mercuration, oxymercuration, demercuration kind of reaction. So what happens? We will get enol product first, right? So if I take this question number 157, if you add mercury to this double bond will add to mercury, and this mercury will give its lone pair electron to this, and it will form a three-membered intermediate, right? Mercurium ion. Now you'll be adding water. Now, where does the water attack? Always the addition of this water is anti to this group. This is anti-addition. So, if water gets added to this carbon, this will be highly stabilized. The five-member intermediate will be highly stabilized. So, it will attack to this carbon and this will break. Now, this oxygen will take away electrons from the hydrogen and release H plus. So you will get OH. And if we can add some reducing agent to remove the mercury, so we'll get CH3. Now this can undergo tautomerization. The hydrogen comes here and you'll get a double bond between these two, carbon and oxygen. So you will get this as a product, right? So do we have this in our option? Yes, it's option A, right? This product. Yes. Question number 158. How will you convert butane 2-one to propanoic acid? Look, butane 2-one is this, a ketone. So ketone will not get oxidized by either Fellings or Tollens. So this is eliminated. But since butane 2 won't have this methyl ketone group, I can oxidize this with the help of iodoform reaction, right? Iodine in alkali. So this will get oxidized to carboxylate. Now, if you add H plus to this, you will get propanoic acid, COOH. This Na plus will be replaced by H, COOH. So this is our propanoic acid. So we can use this option C. Okay. Coming to assertion and reason type questions. First, alpha hydrogens in aldehydes and ketones are acidic. Yes, it is, right? So this hydrogen which is attached to alpha carbon is acidic because we have a carbonyl which is electron withdrawing group adjacent to this carbon. So this will withdraw the electron from this, and this will in turn withdraw electrons from this. So hydrogen can move as H plus. So that's why we call this as acidic hydrogen. Now, statement 2, they have given the anion left after the removal of alpha hydrogen is stabilized by inductive effect. No, it is not stabilized by inductive. If you take this anion, remove this hydrogen as H plus, I'll get anion. So this anion is stabilized by resonance, right? These are undergoing resonance. These are being stabilized by resonance. So it is not stabilized by inductive, but by resonance. So this can be considered as a true statement, but this is a false statement. So it should be option C. Okay, next, coming to 160th question. Is RC triple bond is more stable than this. They've given two resonating structure and they're telling that which one is more stable than the other. So they say that this is more stable. Although we observe that here the positive charge in oxygen atom makes it less stable. But if we consider this, the carbon's octet is not complete, right? One, two, three, four, five, six over here. So in the resonating structures, the octet electronic arrangement should be same, like octet should be completed. So since your octet is not completed, this resonating structure is less stable than this. So this is more stable. Yes, this is also true statement. Coming to statement 2, resonance in carbonyl compound provides C plus and O minus. Yes, you will get normally negative charge on oxygen and positive charge on carbon. So we can say that this is also a true statement, but this statement doesn't explain the first statement. So that's why we can say statement 1 and statement 2 is true, but 2 is not the correct explanation for 1. Okay, so it should be option B for this and an option C for this. Okay, so this is all about the solutions of Neet Test 4 on the chapter aldehydes ketone. I hope you've understood everything. Thank you.